Okay, hi everyone. Can you all hear me? Cool, all right. So today I'm going to talk to you about data lake resiliency, essentially, how to build a better, more robust data lake. And I promise not to be overly critical of your favorite tools out there, I hope. Yeah, so my name is Ozcat. I'm the CTO and co-creator of an open source project called lakeFS. That's me on the right there. Presenting with me, that's Lottie. She's our mascot. She's an axolotl. She's our CCO, or Chief Cuteness Officer, which is an important title. All right, so let's talk about what a data lake looks like. This should look familiar, I'm assuming, to most of you, or something of that nature. So we have a storage layer at the bottom, right? On top of that, we now have our new table formats, whether it's Delta Lake or Iceberg or Uniform now, whatever it is that is your favorite. Typically on top of that, especially if we're working with tabular data, we might have a catalog. If we're lucky, we're using something like Unity. If we're less lucky, we might be still using Hive. My heart goes out to anyone still using Hive in the audience. And on top of that, of course, a whole bunch of great compute tools that we love. That's what like the typical scenario would be, right? So I'm going to focus more on the bottom half for this talk, but you would see that they kind of tie together. So one important addition, which is part of every modern data lakehouse, is of course a bunch of Excel files, right? Just putting that out there. Yeah, so let's talk about what resiliency is, or like what are the ingredients that we need in order to create a data lake that's actually resilient, right? That's can withstand failures and keep on ticking. So I broke it down to kind of 3 different categories of things we might be looking at. So the first one would be we want to be able to create a reproducible process, right? If we want to fix something, we want to make sure that we solve the problem, we can reproduce it, see that our fix actually solves it, and continue with our lives. We also need some form of a quality gate, right? We want to release new data out there to its consumers. We want to make sure that the data we're releasing is actually of our preferred standards. And lastly, what we all always wish for is a big red button, right? We want to reduce the cost of mistake to a minimum, right? To be able to say, okay, I screwed something up, and we just hit that button and undo that change. So let's talk about reproducibility first and why it matters. So first, let's try to define what that reproducibility means. So essentially, it means that for the same process and the same input, I would expect, as long as that process is deterministic, to get the same results. Right? So if you think about our data processing, our inputs would be existing data sitting somewhere, right? Whether it's being streamed to us or we're reading it from another table or another data source or an API. And we would have some process that reads it, does something with it, and eventually creates an output. That output could be another data set. It could also be a dashboard, a report, a machine learning model. And when we want to improve any of those, we want to make sure that we're always running on top of that same baseline, right? So if I now have an ETL that takes 2 tables and joins them, and I want to improve that ETL, I want to make sure that I'm keep feeding that same input as I'm testing it, right? Because if I'm getting different results, it could be because my input changed, right? So I want to be able to isolate only the thing that I'm now changing to make sure that it has the desired effect, right? I want to create that feedback loop. This especially matters if you're dealing with like machine learning and AI. So I don't know how many of you would get the reference. Let's say we want to build a machine learning model that, given an image, would tell you whether it's a hot dog or not, right? We're going to use that example a lot, so expect a lot of hot dogs on our slide. For ML, we really care about this, right? Because let's say we build that thing, right? And now my grandma is using that application, and my app is saying that she's a hot dog. She might be offended. And I want to be able to say, okay, this is the stuff I fed into my machine learning algorithm in order to get that result. Right? If I don't have that information, if it changed since I trained my model, it's really hard to capture those bugs and improve my model. So let's try to build something that's reproducible. Okay, so I'm going to use Delta Lake for most of the examples here. These might also kind of be applicable to other data formats as well, such as Iceberg. So in this case, let's say I have an image classification table, and I'm just reading out the labels from that table, right? This could be my feature store or something similar. If I just pull this query and pull this into my machine learning model, I'll get a result. That's great. If I run this tomorrow, I might get different results, though, right? And I want to keep it reproducible. So with Delta and with most such systems, I can always refer to either a snapshot or like a point in time and say, give me the results as of this specific instance. Right? This way, if I run that same query tomorrow or next month, as long as no one like messed with the existing data and replaced it with something else, I'm guaranteed to get back the same results. This, though, can get a bit unwieldy at a point, right? Because typically I'm not dealing with a single table, right? If I just open my Unity catalog now, I will see 2,300 tables there, and it's pretty hard to maintain working this way when you have so many tables in place. It's not that it's not doable, it's just that it takes a lot of bookkeeping to make sure that my inputs are all aligned to the same version, whether I'm using a time step or I'm using just log entries to do this. It takes quite a bit of effort and bookkeeping to maintain that. So going back to that point in time requires quite a bit of tooling and kind of messy SQL, to be honest. Okay, so it's not really that easy to figure out this is where I started from. Putting reproducibility aside for a second, let's talk about these quality gates. So why should we care? Has anyone heard about the term write, audit, publish, about that pattern? Raise your hands if you have. Okay, I see a few. So the idea behind write, audit, publish is essentially like described in the name, right? I'm going to make a transformation. I'm going to have some form of auditing process in place. This doesn't have to be like manual, like an actual person looking at the data. This could be an automated tests. And then once these tests pass, I'm going to publish that output onto its consumers, right? So I want to separate whoever is writing the data from the people consuming the data. Okay, if anyone here was a software engineer or is a software engineer, we typically do this with CI/CD, right? I might have like GitHub Actions in place. I get all the green checkboxes. Once that's done, I deploy to production. Right? I don't typically just write directly my code to production. So why should we care about this? First of all, because in many cases, it's not that I have like a single producer of data and a single consumer. I have this graph of dependencies, right? I'm reading off a stream, I'm writing into my bronze table. Some other process might kick off, do some aggregations, write a silver. And from there, it kind of sprawls, right? Someone else might join a few tables, create another data set from that, or enrich that and create something else. And we end up with this pretty complex dependency graph of how our data flows throughout the organization. So the thing with that is, let's say I'm right at the beginning of that DAG and something fails. By definition, everything depending on that data is either going to fail or be delayed as well. Right? Either I don't have new data to show or I have data that's broken. Right? And that's maybe the happy case, right? If I'm failing, at least my downstream consumers can see that I'm failing. What happens if I succeed? Right? I wrote bad data, but my DAG is green, right? I didn't notice that I'm putting on a bunch of nulls where there shouldn't be nulls. My downstream consumers are just gonna read that, and now they have bad data. Right? And it's really hard to kind of figure out what the parameter of damage is going to be. And it ends up looking kind of like this. One person screws up, and then kind of the whole thing collapses. So how can we do something like this with Delta? So let's say I have this hot dog table. I can create something called a shallow clone, which is essentially a copy of the table, but it's based on Delta's metadata to actually refer back to the objects, the data objects as they exist in my original table. So I get something that feels and behaves as if it's its own copy, but I didn't actually have to copy all the terabytes or petabytes of data that I had lying around. So with that, I can create a table. I can create that shallow clone. I can do my transformations. In my case, I'm inserting more hot dogs, of course. And then I'm running my audit, right? In this case, I want to do a select to make sure that the bun I'm using is of the correct type. Weird analogy, I acknowledge that. The thing is, the publish step is kind of missing. right? So in Delta's case, either now kind of switching to both tables, saying from now on use the shallow clone as my source of truth, or I have to rerun the transformation again, this time on my original table, right? In which case, I don't really have an audit step anymore, or at least not something I can fully trust. So we talked about reproducibility, we talked about write, audit, publish. Let's talk about big red buttons. And for that, I want to tell you a story about someone who kind of made a mistake in prod. I'm not going to name names, that's the person. Pretty good looking fellow. So I was working previously for an analytics company. We had about 7 or 8 petabytes of data on S3. And there was this one job that everyone hated. No one ever wanted to touch. The name of the job was retention, right? This job deletes data, right? It would look for different scenarios where data is referred to by other things, and if there are no more references, it could actually go and delete the underlying files. It's pretty complex logic. And it would take forever to run. It would run daily, and it would take like 12 hours to complete. And there were a few edge cases where data was supposed to be deleted, but was not deleted. It was kind of a mess. So I thought I'd lead by example. I'm going to do it. So I'm going to fix retention. I'm going to make it faster, and I'm going to delete the stuff that wasn't deleted. Long story short, it did finish faster. So I went home that evening, and suddenly, like, I started getting paged, and paged, and paged, and paged. By the way, for the kids under 35, that's a pager. That's what we had before cell phones. These existed. Our entire Airflow was suddenly red all over the place, even stuff that's kind of unrelated to the stuff I touched. And I had no idea why. So I talked to the person who was on call. We were both working on this together. We pulled out the graphs. And then he showed me the bytes stored on S3. And it looked kind of like this. Mind you, it was much quicker than what before. So keep that in mind. So not the best experience. We had a sudden drop of about 1 petabyte of data. Okay, about 1 billion objects that were suddenly missing. So we got to work. S3 has object-level versioning. Theoretically, we should be able to restore each and every one of those 1 billion files that were missing. But just getting that list, just understanding which data files actually got deleted by mistake and now need to be restored, that took forever. It took us about 2 weeks to recover from that. This is an analytics company, right? This is what we do. We're useless without that data. So that took forever. And all we wished for was that big red button, right? Take me back 5 minutes in time before that screw up ever happened. I'm going to just go back to that last known good state. So how can we do something like this with our existing architecture? So fortunately, for Delta, there is a restore operation. We can say, take this table, pull it back in time, restore it back to version something, or to timestamp something, right? We have a red button. But it's a pretty small red button, right? What happens if I have multiple such tables? That's the same as we did. I love this image, by the way. Might be my new wallpaper. So we could have gotten away with it. It probably wouldn't take 2 weeks to recover, but it would still require some manual effort to figure out which are the offsets that actually include those deletions, and then restore them one by one to get back to that state. So in terms of resiliency, we have some tools at our disposal, but I think we can do even better. So I'm going to talk about Git semantics for a second, because in the world of software engineering, we have a big red button, right? We can just roll back to a previous version. We have reproducible processes. We have Git commits that we can send out, right? We have tags and version numbers. We have all these capabilities, so why not have something similar for our data as well? So going back to our chief cuteness officer, let me introduce you to lakeFS. That's the project I've been working on along with our team for the last 4 years. lakeFS is a layer between the storage itself and all the components that run on top, right? So if I have Delta tables, if I have Iceberg, if I have Spark Cluster, all of these run on top of lakeFS, and lakeFS creates a facade on top of the storage. Right? lakeFS is not replacing that storage layer, it's just a metadata layer on top. We still have Excel files, don't worry. So what does it do? Essentially, it lets you treat that big S3 bucket that we had with petabytes of data as if it was one giant Git repository, right? At billions of files, at petabytes of data. You create branches, you create commits, you can roll them back, you can do everything that you can do for code, but for the data itself. Right? So the way this works is that lakeFS provides an API on top of that storage layer. There are SDKs for Python and for Java. There's a CLI, there's a web UI. There's even a Spark connector. And it lets you interact with that storage using those branches, using those tags, using these commits. And this could be delta tables, it could be unstructured data, it could be Iceberg. lakeFS is agnostic to whatever format it is that you're using. So with that, let's see how this can improve our lives. So when we talk about reproducibility, why not use a tag, right? A version number. So in this case, I'm using a tag called model v15 prod, whatever name I came up with. All these tables are actually inside a lakeFS repository, right on top of my S3 bucket or my Azure Blob, whatever storage I'm using. And when I create a commit, I'm actually creating a snapshot of all these tables together at a given point in time on my branch. Right? And once I assign a tag to that commit, just like in Git, that tag is fully immutable. Right? If I query that same tag again, if I use model v15 prod a week from now, I'm guaranteed to get back the same results. Right? I have an actual version number I can refer to. This is also very useful as I'm working. Right? Maybe I want to test a new model, a new version of the model, and I want to share it with the colleague. Can you look at these results and see if it looked good to you? I can tag it and say, just use this Unity schema and see if the data looks good to you too. So now we can refer back even across tables, and this could scale up to many, many tables and, again, petabytes of data. And I do it using just one tag representing all this together. Going back to the write audit publish example. So remember hot dogs over time. I want to be able to run a transformation. In this case, I'm doing it on an isolated lakeFS branch. Okay, so the example here is using the Python SDK. This is how you would create a branch. I'm calling my branch ETL and today's date, branching out of my main branch, just like in Git. And then I'm running that transformation. Right? I'm inserting into my table. I'm running my data quality tests on my isolated branch. And important to say, when you create a branch in lakeFS, it's copy and write, right? So I didn't have to copy aside all these petabytes to another location or something like that. It's a metadata-only operation, essentially just creating new pointers to existing data. So this takes milliseconds, and it only takes up the storage of the stuff that you modified on that branch, right? So no need to duplicate the storage. So I'm running these quality gates, and when I'm done, I'm atomically merging my changes back into my production branch. And just like in Git, what we typically would recommend is to set that main branch to be a protected branch, meaning I don't want anyone to directly write to it. I only want people to merge into it. Why? Because I want to ensure that that pattern is maintained. And I'll show you later how you can take that select query, right, that quality gate that we implemented, and actually put this as a condition, right? Just like in GitHub, I want that green checkbox, and only if that passed, I want to be able to merge. So in a perfect world, all my transformations are now looking like this. Right? If you remember that big DAG from before, what if I could, for each step, branch out, run modifications on multiple tables? Some of them might be delta tables. Again, some of it might be even unstructured data. Commit them, run the tests, and if that's successful, merge. This is very useful, especially when we talk about that big red button. Right, so this is the lakeFS UI. In this example, I'm showing a commit log for a repository. And here, I'm referring to a specific commit. Right? This could be that person whose name we're not going to mention that deleted a bunch of data. This is the commit ID. Right? This is retention now running. This is the person screwing up production. And with lakeFS, you can actually just say, OK, let's take that commit ID for that repository, and do the inverse of that, just like in Git. Right? Whatever files it deleted, I'm going to restore. And essentially giving us that big red button that we really wanted. So what do we get? We get something that's very easy to reproduce with. Right? We're using the power of both Delta Lake and lakeFS to achieve that. We're using the quality gates for write, audit, publish. And we have a big red button, right? We can actually revert stuff. But I promise you we'll circle back to that Excel file. So we probably don't want those, right? CSVs, it's 2024, we can do better. Let's show an example of how those hooks, those quality gates can actually be useful to make sure we don't have any of those. So what if we could apply the same pattern here? And this is an actual example of a lakeFS hook. That's what it would look like. So you would put inside your data repository a hook file. In this case, it's a pre-merge hook. And I would say that if someone's going to merge something into main, don't allow it if it ends with .csv. That's kind of a naive example, of course. But imagine taking this one step further for, let's say, schema validation, right? Make sure that these columns are always maintained. Or to do stuff like referential integrity, right? If I have a foreign key, make sure all the primary keys for it exist, right? To maintain consistency between tables. So lakeFS lets you implement all of these before data actually reaches your downstream consumers, right? So if I'm a user and I'm consuming data now from the main branch, either I see data that has been validated and I can actually see the code of the tests that I pass, right? This is actually my contract, or I don't see new data at all. And one thing for sure, I'm not going to see CSVs in this example. Yeah, with that, I'm done, and I'm happy to answer your questions. OK, if you guys have any further questions, we're at booth 69. I didn't pick that number, I swear. So feel free to jump by our booth. You can grab a plushie of our CCO. And thank you, everyone.